Here we go. All right, in chapter 9, we are going to continue hypothesis testing. But instead of us just testing a mean for a specific value, like testing to see whether a mean equaled 850 or if a mean was less than 300 or something like that, we're now testing the difference between two means. So all the steps are going to stay the same. How we state our hypotheses will change, and our test value formulas will change, but that's it. So how we find critical values, how we decide to reject or not, how we summarize things, those things all remain the same. So just to give you an idea of what we're looking at, we have a researcher wishes to compare, there's one big key word right there for us, compare the average lifetimes of two different brands of AAA batteries. They're not interested in the average lifetime of all batteries. They're looking at comparing the two means of the two brands. So last unit, we would have said something like the mean, we're trying to claim that the mean average lifetime of AAA batteries is 45 hours. That would have been last unit. Now this unit, we're looking at comparing the average lifetime of brand A versus brand B. So two different means we're looking at comparing. So how you state your hypotheses, you still have our H sub 0, H sub 1, our null and our alternative. The null hypothesis will still state the equal to piece, just like we had last unit, but note the difference. I don't have mu equals 25, I have mu sub 1 equals mu sub 2. The little subscripts, they don't mean anything computation-wise for us, they just help us distinguish between which population we're looking at. So in this case, mu1 is brand A and mu2 is brand B. You have to make sure when you write your hypotheses, you have to make sure you specify, like I did up here, which population your mu1 and mu2 are coming from. Otherwise, I won't be sure if you're making the right comparison or not when you write the rest of your hypotheses with your symbols. Now, another way, when you're comparing them, if you're saying that the two means are equal, that's the same thing as saying that their difference, by difference we mean subtract, is actually 0. So if the two are the same, their difference would be 0. If the two are different with the not equal to, their difference would be something other than 0. So we have to keep in mind that second way to state those hypotheses, because sometimes when we're comparing, we're looking to see if the average lifetimes of brand A and brand B differ by 5 hours, or that they differ by 10 hours. We can look for a specific difference, and if we have a specific difference in mind, we have to state our hypotheses that second way at the bottom. So just something to keep in mind, and we will see that today. Our assumptions, both samples are random, the samples are independent, and the standard deviations, and here it is, this is the common theme, guys. Standard deviation of the populations are known. So confidence intervals, when we did a z-interval for confidence intervals, z-interval for a mean, we knew the population standard deviation. For a z-test for a mean, last unit for our hypothesis testing, z-test for a single mean, we had to know population standard deviation. Now we're looking at a z-test for comparing two means. Population standard deviations we have to know. So if you haven't gotten it the last two units, here it is again, third time, property hasn't changed. If we're doing a z-test, population standard deviations, we need to know those. All right, the theory behind it, how we come up with some of the things we do. You select pairs of samples and compare their means. Again, it's a z-test for comparing two means. You don't need to know the population means. If we knew the population means, we wouldn't have to do any of this. In order for this to work, though, you have to take all possible pairs of samples from your populations. The means for each pair of samples, you compute them and then subtract. The differences, so after you subtract, you plot them. If both populations have the same mean, the differences will be 0 or close to 0. The curve will be shaped like a normal distribution with a mean of 0. So that's what happens when we plot our differences. And then our formula for this, all things that we're very, very familiar with. The X bars, remember, those come from your sample. Those are your sample means. The question that I had a few people start in on this yesterday. And they said, oh, Miss Golly, what do I put in for mu sub 1 and mu sub 2? You said we don't know the population means. And you're right, we don't, because if we knew them, we wouldn't have to do a hypothesis test. We'd already know the means, we could compare them. So what that is, it's your hypothesized difference. It's your hypothesized difference. So if I don't say I'm looking to see if the difference between brand A and brand B is 5 hours, if I don't have a specific difference, then mu sub 1 minus mu sub 2 will equal 0. Now if I happen to say I'm testing to see whether the average lifetime for brand A compared to brand B is greater than 5 hours, then I'd have my mu sub 1 minus mu sub 2 would be that specified difference of 5. So if you're not given a specified difference, and again, we'll see each case today, then this quantity right here will be a 0. So you're just going to put a number in there. You will not know mu sub 1, you will not know mu sub 2. You will not know those things. In the denominator, just real quick note, these are, just a reminder, that sigma squared is population variance. Now we talked about needing to know population standard deviation. So you're going to have to, if you're given population standard deviation, you're going to have to square it when you put it into the formula. The lowercase n's are just your sample sizes, and they have the subscripts just so we know which population they're coming from is all. So, before we try this out, the results, if your difference ends up to be not significant, your null hypothesis is not rejected, and you conclude that the population means are basically the same, that they'd be equal. If the difference is significant, that's when you'd reject the null hypothesis and you'd conclude the population means are something different. Now this table, it's not in your section, so it might be something if you didn't jot down in your outline when you outlined yesterday, you might want to go back on and get this outlined. The top way is okay for most cases where you have mu sub 1 on the left side and mu sub 2 on the right side. But the bottom cases, these are when you're going to use if you have a given specific difference. Now I know when I made this table, I put each difference as just being 0, but that 0 could be anything. So again, if we thought we're trying to show if the average lifetime of brand A versus brand B, if brand A was greater than brand B by 5 hours, we'd put a 5 in there instead of a 0. So if you're given a specified difference, the 0 will become whatever your number is, whatever your difference is. So let's go ahead and let's try this out. We have a random survey of 1,000 students nationwide, showed a mean ACT score of 21.4. Ohio was not used. A survey of 500 randomly selected Ohio scores showed a mean of 20.8. If the population standard deviation in each case is 3, can we conclude that Ohio is below the national average? So now before you can start writing your hypotheses, first of all, you want to pick out what kind of test you're using. I know, it's the first section, so, well, Miss Guy, it's a z-test, because that's what this section's about. The reason why, population standard deviation, we know it. That's the why we're doing what we're going to do. And again, it's been the same for confidence intervals. It was the same when we were testing just one value last unit. So that theme does not change for us. But what we do need to do a little different is we need to designate what mu sub 1 and mu sub 2 are going to be. Otherwise, when we go to make the comparison to show that Ohio is below the national average, I won't know which one is the national and which one's Ohio. So I'm going to make mu sub 1 I'm just going to go with national, ACT, and I'm going to make mu sub 2 Ohio. As long as you label them, you're absolutely fine. You could switch what mu sub 1 and mu sub 2 are, and then it would just change what type of tailed test that you have. That's all it will do. So don't freak out and think when you're doing your assignment or you're doing your test, you're like, oh, but what if Miss Golly put Ohio as mu sub 1 and I put as mu sub 2? It's not going to make a difference. It will not make a difference. You just need to make sure that you designate for me which one's which. Otherwise, I won't know if you're making the correct comparison or not. You have to designate that for me. So now, we're not given a specified difference. We're not looking to see if their averages are different by 2 points. We're just looking to see if Ohio is below. So we can use mu sub 1 equal to mu sub 2. And then here's where the labeling, here's why it's super important. I want to show that Ohio is below the national average, or that it's less than it. So what type of inequality symbol do I need? I need a greater than, because mu sub 2 is Ohio. Now if I don't label those, I don't know what to put in there. I don't know what to put in there. And then we do have to state our claim, and we're trying to show that Ohio is below the national average. Now, another okay way to state these, if you want to, you can show it with the subtraction. If you want to, that's totally fine. It's up to you. You can show it either way you want. They mean the same thing. Up to you. All right, so now, step 2 hasn't changed. Step 2 is critical values. It's a z-test. So I'm going to write down a few important pieces of information. Alpha is 0.05, and I have a right-tailed test. Totally up to you how you want to find those critical values. A lot of you are plugging and chugging in the calculator. Z-test, so you'd use inverse norm. Or you can go to table E and look for 0.95 on your table. So remember, we're a right-tailed test. Whoops. There we go, we're right-tailed. This is 0.05, so we need to find the z value. So I have 0.05 to the right of it. Now I know some of you, when you do the calculator, you'll just put in the 0.05, but then what you get out of that is negative 1.6. If you do the calculator, you get 1.64. But we're on the right side, so we'd have to make sure that we switch it and we go positive. Remember, whether you're doing the calculator or you're looking in the table, you want the area to the left. That's what you want to be able to put in. That's what you want to look for in the table, or that's what you want to put in your calculator. I know some of you shortcut it. You do the 0.05 and you adjust from there, but just make sure that you adjust. This was kind of that goofy one where if you do the calculator, you're 1.64. If you do the table, you're 1.65, and it's not going to make or break us either. It'll be fine. So step 1, a little bit different for us because we're now comparing two means. So we have a mu on each side of the equal sign or inequality symbol. Step 2, though, guys, critical values, that's same stuff. Same stuff that we've been doing. Step 3 is still our test value. Different formula, but step 3 is still our test value. So into that formula, we have x bar sub 1. That's our sample mean for whatever we designated to match up with mu sub 1. So we want the sample mean for our national ACT, which was 21.4, minus the sample mean from Ohio, which was 20.8. minus, now here's where we have the mu1 minus mu2. Mu1 minus mu2, we're not given a specific difference, so it's just a 0 in there. If you are not given a specified difference, like we're not looking for the difference in the averages to be at least 2 points, we're not given a specific difference. So we just use 0. In the denominator, we have a big old radical. Population variance is needed. So we take our standard deviation of 3 and we square it. Divided by sample size. We had 1,000 students for the national. And 500 for Ohio. So now just take a minute, enter some things in, see if you come up with what I did. Double check me, make sure we match. And if you match me, then go ahead. Steps 4 and 5 haven't changed. So go ahead and do your steps 4 and 5. .65, our test value falls in that shaded region. It'd be somewhere way over. I'd have to extend this out. Be somewhere like way over there somewhere. 3.65-ish is in the shaded region. So if we're in the shaded region, we reject. And when you reject, guys, and I know that a couple people on the test do this, step 4 has nothing to do with your claim. Step 4 is all about the null hypothesis. So whether or not you reject the null or not. Step 5 then is where you bring in your claim. So if I reject the null, that means I get to support my claim. So there is enough evidence to support the claim. The claim that the average ACT score in Ohio is below the national average. And again, it's never specified how far below the average it is. There's no specified difference. So that's why we use the difference of 0. So since we rejected the null, there's enough evidence to support our claim, which was the alternative hypothesis. So again, not a whole lot new, really. How we have to state our hypotheses now that we're comparing two means, that's different for us. All the steps are all the same. The formula we use for the test value is different, but everything else is the same. How you find the critical values, how you decide to reject or not, and how you summarize. Those things haven't changed for us. So if you're still kind of getting there from last unit, here's your opportunity to really get a handle on that. All right, let's take a look at another example of this. This time, though, if we take a read through, you have the average sales price of new one-family houses in the Midwest, roughly $250,000. In the South is $253,400. A random sample of houses, of 40 houses in each region was examined with the following results. 0.05 level of significance. Can it be concluded that the difference in mean sales price for the two regions is greater than $3,400? So a couple of things with this one. First of all, how do I know I'm doing a z-test? Because I know the population standard deviation. This time it's given to me in a table. It's not up in the question itself, but it's in the table. So I am given population standard deviation. The difference between first example and this one, can it be concluded that the difference in mean sales price for the two regions is greater than $3,400? So this is what I've been talking about. I know I keep saying a specified difference, and I've been making up some kind of random number to go with that. But here's where we're actually looking at, is the difference in the means greater than $3,400? That's what we're looking at. So we have, first of all, to designate mu sub 1 and mu sub 2. Now for this one, we're looking for the mean sales price to be greater than $3,400. So what I want to do, I'm looking at what they are projected to be from a different study. And I'm going to put the one that is larger, since we're looking for a difference greater than 3,400. I'm going to put the one that is larger as my mu sub 1. Now, this question isn't stated all that well. They're just looking for that the difference for the two regions is greater than 3,400, but they're not really saying which one is the greater one. So you have to kind of read into it a little bit more and look at which one starts off as being the greater one, and that's what you should use as your mu sub 1. We are not given quite all the information that we need. Alright, so when we state our hypotheses, this one there's actually a difference, so I can't just put mu 1 equals mu sub 2. I have to show that their difference equals the specified difference, which in this case is $3,400. And then in the alternative hypothesis, we want to know if that difference is greater than $3,400. So since we're looking for the difference to be greater than 3,400, again, that's why I put the south as my mu sub 1, because in the original, the previous study, the south was larger than the Midwest. So now, step 2, actually you guys can go ahead and take care of the rest of the steps. See what you come up with. I'll start putting them up here piece by piece. You should be able to find critical values for a z-test very easily. Step 3, try out that test value formula. 4 and 5, reject and conclusion. Those things haven't changed. Those things haven't changed, so I'm not going to keep taking up a bunch of your time on those things. Give you guys some more time to practice. Bless you. So check your steps with mine. Let me know what I can help you with. I just made a little note for you guys on step 3 that when you're doing the test value formula, your difference for mu 1 minus mu 2, the difference is $3,400. It's not going to be the 0. So be very careful on that part. Otherwise, check yours with mine. I'll be around. Let me know what I can help you with. Now, just like with our last round of hypothesis testing, we can also find confidence intervals for the difference between two means. Now, this confidence interval, though, isn't something we did with our first round of confidence intervals back in chapter 7, excuse me. So this confidence interval is new for us, but what we're looking for is if you're hypothesizing a difference of 0, so this would mean mu sub 1 equals mu sub 2, or mu sub 1 minus mu sub 2 equals 0. If you're hypothesizing a difference of 0, if your confidence interval actually contains 0, we don't reject the null. If your confidence interval does contain 0, then that's when we would choose to reject. Or if it does not contain 0, if it does not contain 0, that's when we reject. So it's just like the confidence intervals with our last round of hypothesis testing. If our hypothesized mean was in the interval, we didn't reject. If the hypothesized mean was not in the interval, that's when we did reject. So it's the same idea. Same idea. So you have to look at what difference are you hypothesizing. Is it 0, or is it like our last example of 3,400? So whatever you're hypothesizing, if that if that difference is in the interval, we don't reject. If that difference is not in the interval, then we do reject. So let's try out a confidence interval. Now, unlike the last one, guys, since we really haven't had these confidence intervals before, we're not going to do a full-out hypothesis test and see if they agree and all that. I just want you to focus on the confidence intervals. So we have the average credit card debt for a recent year was $9,205. 5 years earlier, the average credit card debt was $6,618. Assume sample sizes of 35 were used, and the population standard deviation of both samples were $1,928. So that's how I know I'm going to do the Z interval. Population standard deviations, I know them. So we're looking at 95% confidence interval of the difference in means. So, still want to designate mu sub 1 and mu sub 2. We still want to designate. So let's make mu sub 1, let's do recent year. And let's have mu sub 2 5 years ago. Again, it shouldn't matter if those are interchanged. Shouldn't matter. Alright, so we're not given a specific difference. So mu sub 1 equals mu sub 2, or mu sub 1 minus mu sub 2 equals 0. That second option, guys, might be the way to go for you when you're looking at a confidence interval. Because confidence intervals are all about seeing if your difference, your hypothesized difference, is in that interval or not. So writing them the second way, it makes it a little bit more clear of what your difference is versus mu sub 1 equals mu sub 2. So just a suggestion, you might want to go it the second way when you're looking at the confidence intervals. Now, the reason why I did an equal, not equal, because there's nowhere in the question that says we're trying to show if one was greater than the other or less than the other. So same as with our last round of hypothesis testing, if it's not specified, just go with the other. Now notice, we're not taking these, again, we're not taking these to the extent of we're going to have a claim or anything on this one. It's all about just getting you familiar with the confidence interval, that we've never seen this one before, and just seeing if 0 or your hypothesized difference is contained or not, and what that means for your null hypothesis. That's all we're looking for. So we have 95%. So we need alpha, 1 minus our confidence level. Now we need z sub alpha over 2, so now we've got to divide everything by 2. 5. Alright, now this formula is kind of big, so here we go. I'm going to start way over here. Our sample mean for the recent year was $9,205. We had $6,618 minus, we have z sub alpha over 2. So we have our alpha over 2. So again, you have your choice. You could find 0.025 in the body of table E, or you can do the inverse norm on your calculator. Totally your choice. That one will come out to be 1.96. And I know, same with Miss Galley, you're just breezing right through that z sub alpha over 2. And you're right, I am, because this is now our third unit with z sub alpha over 2. So if you still need some help with that, you gotta let me know. Then we have population variance. So 1,928 squared. And sample sizes were both 35. We have to be careful. This confidence interval is looking at the difference between two means. So that's what I have to symbolize in the middle of my interval. We're looking at the difference. So again, the more we get into this, the more you might be thinking, yeah, Miss Golly, I think you've got the right idea for me there, that I should state my hypotheses that second way. That second way shows me I'm looking at a difference of 0, or whatever the difference happens to be. And then it also helps me match up what my symbol should be in the middle of my interval. So just an idea. And then the other side is the same deal, but we add. Alright, so play around with that a little bit. Double check me. When I did this, I came up with $1,683.67 and $3,490.33. So play around with that a little bit, do a little plugging and chugging, and then we'll talk about now if we found the interval. Now what does that mean in terms of rejecting or not? So once you have your interval, again, we're not going to do the whole 5-step hypothesis test and then bring in the interval. I just want you guys focusing on, we haven't had these intervals before, so just focusing on the interval and then what that should mean for your null hypothesis. So if I look at my interval, my hypothesized difference is 0. My confidence interval does not contain 0. So the null hypothesis, which says there should be a difference of 0, has a mind of its own. There we go. So the null hypothesis, which says the difference is 0, would be rejected. So if your confidence interval does not contain your hypothesized difference, then you're going to reject your null. Now, if that interval did contain 0, then we wouldn't reject. So it's the same as we saw last unit with our confidence intervals. If our confidence interval didn't contain our hypothesized mean, we rejected our null. So same idea here, except for now we're looking at a difference. On your sheets, you do have an assignment. I don't know how I got the page numbers wrong. I have the technology pages right, but I have these page numbers wrong. The pages should be 494 to 497. And they match with 9-1, so I don't know how I got those wrong, but they got the technology right, so sorry about that, guys. Now, I do want to show you, I'm not going to spend a ton of time on the technology piece. I want to get you guys some time to work. I just want to show you where to go. The technology steps are starting on page 497. We go to Stat. We go to Tests. Now this time, actually just let me arrow down a little more so I can get both options on the screen at the same time. There we go. So, If you want to do the hypothesis test, you want to do the z-test for comparing two means, this is for your hypothesis test that we did. It's a two-sample z-test. Now, if you want the interval, the confidence interval, it's option 9. It's a two-sample z interval. All the variables and things that you've been entering in, they're all labeled the same in there. There shouldn't be anything that you're not sure what to put in for. If there is, I can help you out with it. If you're going calculator way and you're not sure what to put in, let me know. But again, just a word of caution, these options do not work. Mu sub 1, mu sub 2, you have to be hypothesizing a difference of 0, otherwise they don't work. So this would not work when we were hypothesizing a difference greater than 3,400. Will not work for those. You have to use a formula for those. So just cautioning you there on that. So they'll only work if your difference is 0.